I feel like this is the last thing we need to learn, and that is how to do the FRQ if it's a difference. So if it's a two sample situation. The good news is it's just really not that different. But when we do two sample stuff, do you guys remember me saying that it's like kind of irritating because you have two samples that you have to deal with? So the only thing is it's not hard, it's just kind of irritating. Um, because you've got like double the conditions and whatnot. So let's go slow here. We're just gonna outline what we're gonna do. I'm gonna add one thing that's new, and then we're gonna do the example, which I believe you guys need to cut and paste in um, about job security. Okay, anyway, so four-step process. This is what we're hopefully working on memorizing right now. The state is the same, so state the parameter. You want to estimate. In this case, the parameter is going to be a difference in proportions. Because you have two samples, you're going to calculate the difference. Um, so you guys know where this lives on the yellow sheet, I'm hoping. And percent confidence. I'm going to try to find my yellow sheet here because we're going to go to that, of course, in 2 seconds. Seems to be lost. Nope, it's right here. Okay, so we're in this region. Okay, plan. Identify the inference method. What does inference mean again? Backward stats magic. It means taking a sample and using the information from the sample to estimate the population, which is what we do all year, basically. Identify the inference method and check conditions for both samples. Okay, that's the annoying part right there. The rest of it's not too bad. Okay, so I want you guys to, again, lean heavily on the yellow sheet. So for the do, hopefully you guys know that it's calculations. So I'm going to bring up the bit on the yellow sheet about confidence intervals. So statistic plus or minus critical value times standard error of statistics. So the middle plus or minus how many standard deviations on either side. Okay, let's go through these three things slowly. If the parameter that I'm estimating is P1 minus P2, what would the statistic be for that? Let me say that again. If the parameter I am estimating is P1 minus P2, what would be the statistic I am estimating? What do I do to things to go from population to sample? What do I do to the symbols? Hats. Right. Good job. Okay. I really want you guys to know though that this bit right here is one number. You're going to have a decimal here and a decimal here, and you're going to subtract those. Okay. Plus or minus. Okay. What is the critical value? What's the symbol for that? Z star. Great job. And what is Z star? It's the number of standard deviations on either side, absolute value, because you're taking account the sign with the plus or minus already. Okay, now you're here, and standard error of statistic is located on the other side of the yellow sheet. So flip that over. And you're in the two populations line. So your standard error is this one over here. We only use two this chapter, this one and this one. Please do not go here in your brain. This is not this chapter. It's just this one and this one only. Those are your only two options. I will explain the other one soon enough because time goes so freaking fast. I don't know if anyone noticed. Okay, here's something really really embarrassing. I don't really think I needed all those lines. Okay, so we're just gonna say so you're going to use the sentence to interpret the confidence interval. Okay. This is kind of weird. Okay. I just put way too much space. So, okay, right under here, you guys do not need all these lines that I left. So I'm gonna scooch this down, but you can put it right underneath. I just wasted a bunch of paper. I don't know why. Not all research studies are surveys. Some of them are experiments. Do you guys remember in chapter 4, we had that big section that was observational study and experiment. Surveys are observational studies. They're just asking something and you're replying and you're not changing anything about your behavior. You're just like, this is what I do. That doesn't mean that all observational studies are surveys. Some are just like, getting numbers off of people's medical records and calculating statistics off of that, or, off of databases with information, just getting measurements or GPAs or whatever. But when you're doing a difference of proportions, a lot of times that's where experiments start to come in as some of the research studies that you look at. So what I mean by that is when you're reading the problem, it's not going to say random sample. It's going to be an experiment instead. Okay, which means that the conditions have to change a little bit because random sampling isn't really something that takes place with an experiment. So if you remember, it's unethical to randomly sample someone for an experiment and make them do it. You can't, except for that I sort of did that to you. But anyway, I mean, if you're actually really doing an experiment, you should not randomly select someone for your experiment. Do you guys remember what you do instead for experiments? You don't random sample. What do you do instead? Random assignment, right? Okay, so really quick, look at me. Look at what I had right there. Oh man. Okay, so random sampling is surveys and observational studies, and then random assignment is experiments. And I would just not ever lose this paper if you can help it. Okay, anyway, in the problem, it might not say random assignment directly, but there should be some kind of description that sounds like random assignment. So I'm gonna say usually random assignment. And it should sound like random assignment, or it should say random assignment, or it should sound like an experiment. And then you should have random assignment. Okay. The 10% condition, if you have an experiment, it doesn't apply because you're not randomly selecting out of a hat or worried about independence. So okay, so you're wondering, as a student, what do I have to write? I know that's what you're wondering. What does she want? What does she want me to say to the 10% commission? You can completely skip it. You don't need to mention it. You don't even have to say 10% question mark. However, I don't know if in my homework or any of my keys, I will ever do that. I will put 10% question mark, 10% condition does not apply. I'll say something like does not apply. And the reason is because I just like to go random 10% large count, random 10% large count. I just like to have that like little pattern in my brain. And so I'll just say does not apply. You do not have to do that. It's up to you. You can just skip it completely and just not even mention it. College Board's not gonna care. And I won't care. It's just that I can't do that again, because I'm a Virgo and extremely linear thinker, so I have to have something in each spot. Like I want all my stamps. I don't know. Anyway, okay. And then large counts is its usual self. I really like to find experiments in my problems because that means that I don't have to think about the 10% condition though. It's less work still. Now this is awkward, but I'm now going to flip my notebook over because I did the whole other example on the other page. You can decide how you want to proceed with your notebook page, but I'm going to start at the top of the next page. Again, it's up to you. Oh, I didn't put the thingies on the tables. Yeah. Can I what? I went down to the bottom. I took up this whole page for this whole problem. Yeah. Me, though, you know how much extra room I leave and stuff. So like Cameron, here's last year's. Cameron, here's last. Okay. You could be one of those people that could be fine with like, say, part of the problem being on one page and part of the problem being on another page. I don't know if I can live that way, but you probably can. She slept, she don't slept. She's does, she's like, she's full Aria. She's not Aria. Oh, yeah, yeah. This is the last bit, right? Tomorrow we're doing the ones in here. There's nothing in the notebook. And then starting the team test, because it's a block day tomorrow. It's so weird. Okay, guys. All right, here we go. State. State says, state the parameter you want to estimate P1 minus P2 and percent confidence. I will start with percent confidence because I feel like that's the easiest way to say what I'm doing. So 95%. Okay, now pause here. There's actually two ways to proceed from this moment. Does it make sense that if it was a one sample one, you would now say P equals the true proportion? Okay, and we need to put something minus something because it's the true difference in proportions. There's two ways you can do the problem. You can assign them little subscript letters. So in this case, like PM minus PW, men and women, or you can go P1 minus P2 equals the true proportion, and then you have to put in parentheses men minus women. I think it's easier to just assign the order of subtraction inside the parameter itself. It's less work than to do the parentheses. It's up to you though. If you want that 1 and 2 to match the 1 and 2 on your yellow sheet, then you could do it the other way. I'm going to do it with the letters, and then I'm going to show you how I do it without the letters on a different page. But anyway, so I'm going to say, do you guys see how it says men first and then women here in this order? So I'm going to go PM minus PW equals the true difference. And then I'm going to head up to the problem and start copying off the problem. Are there any questions about the state? Not California. I have lots of questions about that state, but do you have any questions about how I wrote the state here? You sure? You're all good? Okay, now let me show you the other way to do this problem. You could do 95% confidence interval for P1 minus P2 equals the true difference in proportions of, and then I put the order of subtraction in parentheses. So you can do either way. I don't care. It's just depends on your preference. I think this is easier just to say the subscripts of the order of subtraction. I have to tell you that I think I go back and forth in the like homework solutions and the team test key and stuff. Sometimes it's like this and sometimes it's like this. It doesn't matter. Are you guys clear? Okay. Plan. Plan says identify the inference method and check conditions for both samples. Okay, the inference method in this case is a two sample Z interval for P1 minus P2. It's just the generic method that you're going to use in this problem. Okay, do you guys understand that now you have two different options to put there? So you have one sample, I think I put a hyphen, one sample Z interval for P, or two sample Z interval for P1 minus P2. Those are your only options right now. You're gonna have a lot more options, as you can tell from the back of your yellow sheet at some point. But right now, those are your only two options. You good? Okay, Randy. Okay, for randomness, we need to check to make sure that not only are the samples random, but they're also separate from each other. And the book and College Board are going to say independent random sample. And it's really gonna make me mad because independent is being used twice for two different things, and it's the same word. So I don't use the word independent for this, I say separate random samples, because I think that makes more sense. You just want them to be separate from each other. Do we have two separate random samples? Oh, it says independent. Great, great, okay. So independent means separate in this particular case. It does not mean independence for the 10% condition. I hate that. Hate it. Okay. I'm gonna do men first because I'm doing M minus W and M comes first. So I'm going to say N1 equals 944. Do we agree with that statement probably? I think so. I think so. I think that we can safely say that there's more than 9,440 men and 8,060 women. Okay. All right. Now for large counts, we need four numbers. If you guys want to do N times P, all of that, you can. I'm not going to. I'm going to do successes and failures because that's what you would get. So let's start with the men, which is here. How many successes are there? And I don't mean successes as in a good thing. I just mean a yes or an affirmative. How many? 802, right? Okay. All right. And then how many failures would there be? I need a calculator. Now, what's 944? I can't do it. I can't do it. 142. 142. I can't. Does everyone know where I got the 142 from? Okay. How many successes are there in the women's section? 709. And how many failures? 97. Okay, pause here. Do you have any questions whatsoever about where I got any of these numbers from? Please make sure it's good. You 100% understand where all of these things came from. So if I tied you up over a pit of crocodiles and said that the only way that you could escape was to explain where these four numbers here came from, you could do it. Okay, just check it. I don't know why it has to be a pit of crocodiles. I think it's because of the greater than less than thing. Anyway, okay, now, yeah, yellow sheet time. So statistic, what is the statistic in this case? It's p hat 1 minus p hat 2. Over here, I highly suggest, actually, we're going to do m. You find them separately first, and I'll explain why in a second. Okay, what is p hat for the men? 802 over 944. And what is p hat for the women? Perfect. And we'll find decimals for those because I just can't work with those fractions. I could, don't want to. That's unattractive. Okay. Does anybody know why I might want to find these numbers separately instead of just going straight here? Because I'm lazy and I have to use them in the standard error formula. So I want to just cheat off of the work I did over here first. I know. Okay. All right. So statistic is negative 0.03 right there. Plus or minus. Okay. What is the critical value for 95%? 1.96. I'm going to go with 0.016 here. Hmm, that's fun. You guys have any questions about the calculations? Does anyone have different numbers than me or anything? Or think I did something wrong because it's Monday morning at 9:10? I don't think so, but okay. How do I start the conclusion sentence? We are okay. And then once you get to the word truth, go up to the state and start copying off yourself. I'm just going to ask one more question today, and I wanted to write this because I want to talk about that, but go ahead and set the rest of this up. This is the end. Think about what do you find? Because it's really, it feels very abstract because you just got a bunch of weird decimals. Like what is your answer actually meaning? Like, what did you find? What did you do? What does this show? Because I mean, I know you guys can go through the steps. I know you can go through the process. I know you can calculate me some good looking decimals. Woo-hoo! But it's much more important to me that you know what those decimals represent or what it's saying or what the question is asking and what this is answering. So this is saying that a plausible range of values for men minus women is -6% to like 0.2%. Okay, the negative side means that sometimes women care more than men. The positive side means sometimes men care more than women. Okay, let me say that again. The negative side of the interval means that sometimes women care more than men about job security. The positive side of the interval, which is smaller, but it's a little bit, are all of the times when men care more than women about job security. Does that make sense? So this has both signs in it. Okay. Does your interval provide convincing evidence of a difference? No, because sometimes it's negative and sometimes it's positive. Sometimes it's negative, meaning that women care more. Sometimes it's positive, meaning men care more. So it does not provide convincing evidence of a difference. However, we're not going to write it like that. We're going to write it in a much more succinct way. I do care about you seeing the positive and negative possibilities, but what we're going to say is no, since 0 is in our interval, since 0 is in our interval, there is the possibility of no difference. Remember, that interval had all plausible values. This is saying that 0 is a plausible value, which means that there's possibility of no difference at all. 0 is a possible answer. But the reason is because it goes from negative to positive. So there are some times when each of them care more, or it could be nothing. So when you do these difference ones, you're going to be hunting for 0 in there, and you're not going to be weirded out by the fact that it's negative sometimes. Okay, so you've now learned everything for the chapter, which is great news.